And this is our section 3.2. In this section, we are going to be finding an equation and using it to make predictions. We're going to talk about the rule of fours in real-world problems, and we're going to focus on the words into a model. And we're going to do unit analysis. I'll talk about unit analysis for a linear model in two different ways. And finally, we're going to wrap up with graphing some vertical and some horizontal lines. X equals A equations being vertical and Y equals B equations being horizontal. So we're going to first of all start out with the points that we need to find in a word model to give us a linear equations model as a formula. So first of all, we have baseline, which is our starting point. Remember our SUV model that we talked about before in Chapter 1? When we had that SUV and when we drove it off the lot, it was worth a certain amount of money. We paid a certain amount. That's our baseline. That's our starting point. And then the rate of change comes into play. Every year, that value of that SUV goes down. That's the rate of change. It's the amount of dependent change by each increment of the independent. So how many units does it go down this way for every one that it goes over this way? That's the rate of change. And we call that the slope. That's what I've talked about in that y equals mx plus b. The slope-intercept form. And then we also have our independent variables and our dependent variables. Our independent is the thing that we are inputting. So in our SUV model, it was the years, right? 1 year after, how much was it worth? That was the dependent value, the y. So our model is going to look like this. It's going to look like the y is equal to the rate of change. How many dependents does it change for each independent, then multiplied by the independent, and then we add the baseline to that. Now, when our rate of change is negative, that means we're doing a subtraction problem, and when our rate of change is positive, that means we're doing an addition problem. So in our SUV problem, the value was going down, so we had a negative rate of change. We saw the line went down this way, whereas when we have a positive rate of change, the lines go up this way. And we'll talk about that more in next section of the chapter with the slope. All right, now the unit analysis comes in here with the rate of change and the independent multiplying. So we have the dependence value in the numerator over the independence value in the denominator. And when we multiply the units here, dependent over independent, times the independent value, the numerator here and the denominator here cancel in terms of units, and so the units here add to the units here, and that's the units of our dependent variable. And so that's one of the things that we'll talk about. Alrighty, now let's take a look at this example. So we have it costing 55 cents to place a long distance call, and each minute that's the independent value of the call, it costs 8 cents to talk. So we want to write an equation to describe the cost of a telephone call, the cost of the telephone call being our dependent. So I'm going to go over here and I'm going to write these things down. So I'm going to write the baseline, and our baseline is how much it costs to make this telephone call, no matter if I talk any minutes or at all. And so the baseline here is the 55 cents. So I'll write that down. And then the rate of change, that's how much does it cost each time I'm going to talk another increment of the independent, which is the number of minutes. So my rate of change here is the 8 cents per minute. So I'm going to have 8 cents, and then we have that over the minutes. So we write that 8 cents per minute. And then the independent values, those are going to be the number of minutes that I talk. So depending upon how many minutes I talk, that's going to be the cost of my phone call. And so then my Y is going to be the cost of the call. And we're going to put that together as the baseline charge. And then we're going to have plus, and then I'm just going to call it rate of change, R of C, and then that's going to get multiplied by the